in that case, Dr. Tsui, thank you very much. I think this is very, very fantastic work, and I hope you will continue to other regions of the spectra using the same method to bring them, and especially around the temperature 37 and around the temperature 4 degrees. I would love to see that you work with the substance that you work at this temperature. Okay, thank you once more. Now I would like to ask, is here Sukkrita Anantawittayanon, called Brim for sure, for so short. Brim, can you please share your...
Can you see me?
Yes.
So my
Within 3 minutes.
in 3 minutes, right? Yeah. So my poster is about the water spectral patterns and the water activity. Can I share my screen right now?
Yes, please.
Okay. Can everybody see my screen right now?
Yes.
So, hello everybody. Today I would like, my name is Sukkrita Anantawittayanon. It's a little bit long, but you can call me Brim. And today I would like to present about the investigation of water spectral pattern and water activity by using aquaphotomics near-infrared spectroscopy. Water activity is a well-known parameter that used in food science to describe the water property in foodstuff. So this study aims to investigate the relationship between the water activity value and water structure through aquaphotomics near-infrared spectroscopy approach. In this study, we used a water activity meter, Aqualab 4TE, and micro-NIR spectroscopy to collect the spectral data in the range of 900 to 1700 nanometer with 5 consecutive spectra. The subject of study include crackers, coffee powder, butter, bread, grains, and grape, which cover the water activity range from 0.09 to 0.96 and used various analysis methods, including PCA, difference spectra, SIMGA, and PLSR analysis. In the spectral data, we can see the baseline difference, which depends on the sample. We calculate the average SNV spectra as the representative spectra of each water activity range. It shows the blue shape in the water activity order. In the different spectra, we can see that free water and loosely bound water region increase together with higher water activity. The first order derivative of the average absorbance spectra also showed clearly dependence on the water activity range. With the water activity below 0.4, the height rate is at hydration water, and in the between 0.4 to 0.8 is at free water, and above 0.8 is at protonated water and trapped water. PLSR model for the water activity prediction show that we can successfully develop the model, and or the ligation vector show the consistency that hydration water and water solution shell always show the negative correlation with water activity, while water molecule with 3 and 4 hydrogen bonds always show the positive correlation with the water activity. So from this study, we can visualize the amount of loosely bound water in the higher water activity system and show that the absorbance rate is dependent on the water activity, which is related to the properties of the water in the system. From this study, we know that water activity is useful parameter. However, it's not enough to describe or the water interaction in the food system. So using aquaphotomics and spectroscopy can benefit to the water study in the food science, and it can increase more possibility for water study and food science in the future. Thank you for your attention.
Thank you, Brim. Do we have a question from the audience? Well, since audience is a little bit shy today, I will discuss questions too. We had many topics at the conference, which from different
Jelena, we don't hear you. Switch on your microphone, please. Yeah. No. No. Switch it.
Where else can your results be applied?
You mean for other type of study in general, right?
Yeah.
So from this result, we can see that water, as the water activity increased, the highest rate of absorbent also changed. So this result could be applied in microorganism and the water structure, and also like to see the possibility and the properties of water in other system. So basically, water activity is used to describe water property in the system in general, but using these water patterns, water spectral patterns can show us more about the properties, the actual properties of the water in each system that can indicate what is the functional of that system further than only one value.
Yes. I think. Sorry.
Alex, do you have a question? Okay. Zoltan, thanks for the nice paper. Yes, you have a lot of in common with Flora Vitali's paper that we saw yesterday. All right, so if
there are no more questions,
please, sorry, there is a question. How did you bring together all the different sample spectra?
How did I bring all together the different? Actually, in this study, I analyzed all the data together, and also like each type of the sample separately. Also, as we can see in this table, that actually the result is come from all samples and like in coffee powder and other samples separately. However, I just show it in like. We can see that all this the result in the analysis of all the samples, and each sample separately still share the same patterns, if that's the question. So
Zoltan, is that the answer to your question?
Yes. Okay.
Anyone else? So Professor Uchida asked the question
Whether your results can be
used to make a water activity meter, and I answered in your name, yes. I hope that's okay. Do you agree?
Agree.
You do.
yeah.
Okay.
Thank you, Brim. Let's, if you have any questions for Brim, for Tui, for other presenters, feel free to interrupt us.
In the chat box. I would now like
Professor Xiri Bian for China
to ask if she's here. She can.
Brim, please close your microphone so Jelena can. Okay.